unit 4 physics that we were doing, they relate to the momentum in two dimensions then eventually. So yes, seemingly not much we have covered so far. All that we have done, just a quick revision, is that we have studied elastic and inelastic collision. For elastic collision, we said that the kinetic energy is conserved. For inelastic collision, we said that the kinetic energy is not conserved. Momentum is conserved in both cases. We said that. Okay. uh okay, and then we said that we came across this formula where we could convert momentum into kinetic energy or kinetic energy into momentum, since both calculations they involve use of mass and velocity. Okay, so this, and then we had we said like any other vector quantity, momentum can be broken down into if the momentum is not along a linear yes, if momentum is not along x-axis, if it's at some angle to x-axis or at some angle to y-axis, we can break it down into its components. And we said that the law of conservation of momentum holds true, but now it has to be broken down into its components of horizontal component and vertical component. So total momentum before collision along y-axis is equal to total momentum after collision along y-axis, and similarly total momentum before collision along x-axis is equal to total momentum after collision along x-axis. This is a summary of what we have covered so far. You attempted a few questions as well. Let's get to this. Exam practice. Okay. You could use your own book or tell me from the screen, whichever is easier for you. Guess I should do it on this thing. For questions, you'll have to do on Jamboard. These first few MCQs, let's see if they're manageable without Jamboard. In any case, yes, we can do use the Jamboard. Am I presenting my screen? You can see my screen, right? Yeah. In elastic collision, conserve momentum but not kinetic energy. Conserve momentum. A. Correct. Okay. Tennis ball traveling with a momentum of 4.2 kgms is hit by a tennis racket. Force of force of 56 Newton from the racket causes the tennis ball to travel back in the opposite direction with the momentum 5.8. How long is the ball in contact with the racket?
Okay, okay, okay. One second. I'm bringing out the question paper with the formulas. Oh wait, this is third one, right?
Second question.
Third unit.
Unit 3. Yes. But, alright. But not necessarily. Sometimes a question in Unit 3 might be using a concept from Unit 1. So, formulas to be used in Unit 3 are not necessarily the ones under the heading of Unit 3. These formulas would be the one that new things you have learned in Unit 3.
Uh-huh. Uh-huh. Sounds interesting. But, but, but. Okay. Momentum, momentum, momentum. All is given is P is equal to mv. So, 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 nothing to do with time, nothing to do with time. Nothing to do with. Uh, I don't know.
Okay, here is a hint. Whenever we're talking about and why is it so slow? Why is it so? Anyways, whenever you have got, be careful when looking at the data given. There is something related to
Yes, impulse.
impulse. And what's the other formula for impulse? You've written, by the way.
Nice. But mine is neat enough.
Still writing on
Okay.
that laptop?
No, I was
Okay.
using
Uh,
another mouse.
Different mouse, different results.
What
Okay.
is the
So,
impulse?
uh, I mean, as a concept or the value over here of impulse?
5.8, yeah.
Impulse we'll have to calculate.
But impulse we have to calculate. So we have only force.
No, no. See, I said change in momentum is equal to impulse, which is mv minus mu. So change in momentum. So basically, what I'm going to do is I'll say that change in momentum is impulse. Also, impulse is equal to force into time. So then I put these two things equal to each other. Okay, so now I will say force multiplied by time is equal to mv minus mu. Force is how much?
58.
56, I think. 56 newtons.
56.
56 into time is equal to mv. Assuming this is the positive direction and this is the negative direction. Um, Initial impulse is going towards the racket, it is 4.2. Going towards the racket, it is 4.2 minus going away from the racket, it is 5.8
5.8.
minus 5.8. So this becomes 4.2 plus 5.8 is 10.
Where is M?
M is not given, instead we are given the complete value of momentum.
Oh yeah. Oh yeah. You're right.
So time is 10 by 56. 10 by 56.18. Is 0.18 an option? And is 0.18
Yes.
the answer? Yes, it
C.
is. It is. Okay.
I
So
told you.
again, we are given that a ball has an initial momentum, so it goes this way. So if towards the left hand side, I take the momentum to be positive. Okay.
Mhm.
So towards right hand side would be what? Towards right hand side it will be negative. No, I took towards right hand side to be positive because force is also in this direction. So two quantities being towards the right hand side, I took mv and f both as positive. So forces acting or vectors acting towards the right hand side, I took them as positive. Can you hear me? Can you hear? Can you hear me now?
Yes,
I'm sorry,
yes.
my internet connection is bad, so the meeting was disrupted. Okay, so what I'm saying is that I
Okay.
took the right hand side to be positive. More of the quantities are given towards the right hand. I mean, force is right hand side, so I took right hand side to be positive. So that, and then yep. So these are the two things that you have to be careful about in this one. First, you have to equate the force into time with mv minus mu, and secondly you
So
have to
here you wrote it's MV minus MU.
hmm.
So isn't MV 5.8?
mv is
And then
4.2. mv is momentum after being hit by the racket.
wait, after is 4.2?
Hmm.
Okay, I didn't realize. I thought after is 5.8.
What is it? What is it? Wait. No, I made a mistake. Opposite direction. 4.2 is initial. Okay,
Yeah,
let's do it that way. By the way, you pointed out the error to be right, but it wouldn't make the difference
right.
because initial it is in the opposite direction minus 4.2.
Yeah. So can you screen share?
I'm sorry, I'll in a bit screen share a window. Or screen share. Is it there?
Yes.
All right, all right. So you got how I solved this one, right?
Yes, yes,
All right.
yes,
Moving
yes,
on to the
yes.
next one. Moving on to the next one. Let me clear screen for this. And the next one. So the next one says in order to calculate the kinetic energy of a non-relativistic particle, we would need to know its.
What's a relativistic
I have an idea, but let me confirm. Non-relativistic
particle?
particle. Non-relativistic particle whose velocity is small with respect to that of light. Something not traveling at the speed of light. In physics, relativistic quantum mechanics is any. Subhanallah. MashaAllah. 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 Applied to radioactive and. Anyways, something not traveling at the speed of light. Hmm. So,
Okay, in order to calculate kinetic energy of a non-realistic, okay, mass and momentum. Okay, so what we need first off to calculate that is 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 half mv square, right? So
No, no. If you remember, we solved over there in the first component of the unit where there were unknown particles, and after collision we find out the mass of the unknown particle, and we found out what I mean equated with a particle of known quantities and said this is that particle. Okay, what we actually need is mass and velocity, or mass and momentum. I mean, if you have got mass and velocity, obviously you'll have the momentum. So we are looking for, in order to identify such particles of unknown, I mean unknown particles, we usually need mass and momentum of these particles.
to calculate kinetic energy,
What do you need to calculate kinetic energy? What are the two quantities that you need to calculate kinetic energy?
mass and velocity,
Mass and velocity. So if you have mass and
and
momentum,
half. What if you don't
and
know half?
half, yes, that's true. So in order to calculate the momentum, I mean if you have got momentum, you can simply divide that with mass and you'll have velocity.
Okay, okay, okay,
So
I
for all
got
the
it.
given options, even the non-relativistic particle over here was just a deviation in order to calculate
It was.
kinetic energy of any particle.
It works. Okay. Um. An experiment to accelerate a trolley along a runway. A light gauge measured the time the trolley took to pass the west. Um. Hmm. Okay. 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 Firstly, sir, can you use calculator?
Yes, please.
0.87
0.87
plus
plus
0.89
0.89
plus
plus
0.76
76.
plus 69 plus 65 and then plus 77 divided by 5.
I mean, what sorcery are you attempting at with changing the order of 0.76 and 0.65? What I love.
I didn't
Okay.
see I didn't see 65 looking at the thing. The what do you say,
Hmm.
back of the paper,
All right.
uh, and then what, into 100 something something.
You added all these values of time, and then
You divide it by 5.
you divide it with 5. You'll have average. Okay.
Yes, yes. And then into 100
200
into 100.
into 100. So you converted average. I mean, you calculated average and you multiplied average with 100. Okay.
What is it?
78.8.
Okay, so it's 0.12%.
I mean, no, no. What's the highest value?
15.
What's the highest? What does it ask us to calculate? Correct percentage error for this set of
I
reading.
forgot how to do that.
Give me just 1 minute. Give me just 1 minute.
15% is the answer though.
All right, I'm sorry. 15% is correct, but how?
Sir, just trust me.
0.89 is the highest. 0.89 is the highest. Oh
Sir, I
my
don't know which one to cut out. That's why.
89. Wait. 87, 89, 65, 76, 77. Even though 77 looks to be 393 divided by 5, I got 78.8. Roughly, I heard that. Okay. Um, 0.89 minus 0.65. 0.89 minus 0.65. 0.24 divided by 0.89. Mhm.
Into 100.
No, no.
Yeah.
0.89. If I ignore that anomaly, 0.89.
But
What's
it's
happening
not
to this
only.
trolley? Same acceleration test.
Excellent.
Along
Yeah.
a runway, light gate measured the time. Light gate is measuring, so there is hopefully not an
Yeah.
error. So highest is 0.89 minus 7.78.
0.65.
Wait, wait.
See,
11%. 11 divided by 0.89. Hmm. It would be something in the range of 15%. The reason being, you take the difference between the maximum and the mean. The mean is the final value that you're taking, and then you calculate it from the two extremes. Okay, so let's see. What's the average value that you got? Average value is roughly 0.78. Okay, the highest value is what? 0.89, and the lowest value is what? 0.65. 0.65. Okay, so now we have to calculate the percentage error for this set. One way is that you say I will calculate the total difference between the two. So what's the maximum deviation from the mean position? That is 0.89 minus 0.65. 0.89 minus 0.65. This is how much? 0.24. And I divide this 0.24 over 0.78, I get 30%. No, I'll have to do it from one end. 0.89 minus 0.78 is how much? 0.11. And this side it says 0.78 minus 0.65 is how much? 0.13, right?
into 100.
No, no, this is just the deviation from the mean. And the average of deviation is 0.12.
7, 7.
So
7, 7.
point,
If you take 7, 7, it will be both 12, 12.
but that's not mean, right? 0.12 divided by
Is it?
0.78 gives me 15.12. Now this is average deviation from the mean on either side, right?
Mm-hmm.
So 0.12 as average deviation as a percentage of reading, you get 15.38%. Again, what you'll do is
Yes.
you'll find out you can take the median value as well, but I resorted to mean. You could have taken the median value. The median value would have been 0.657677. Yes, you could have taken 0.77, the median value, but it's better to take mean
Right.
value. Okay, if I'm taking the mean value, this is the value of this experiment. The answer for this experiment is 0.13. 7 8. Okay, now I'm seeing that how much does it differ on either ends from this 0.78. If it goes the error is on the positive side, how much is it? If error is on the negative side, how much is it? I found out that the two errors, they were 0.11 and 0.13. So I took average of
Alright.
those. If it deviates this way, it's 0.11, that way 0.13. So average, it deviates by 0.12. That is the average deviation. So average deviation over the average reading, which was the reading that I had, 0.78, and a percentage of that gives me 15.38%. This is the answer.
Uh-huh.
Got it?
Okay.
Shall I repeat the explanation or did you get it?
I got it.
Okay. Uh, this, then we have got spacecraft called Deep Space One. This one, 4 marks. You'll have to do some work for this one, and
Okay.
maybe you'll have to do a drawing as well.
Okay. Let's read first. A spacecraft called Deep Space One mass 486 kg uses an ion drive engine. This type of engine is designed to be used in deep space. The following statement appear in the website. The propulsion system. Okay. Mm, Use calculation, count prediction. Okay. 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 So the spacecraft is 486. Mass is 486. Right? And it expels 0.13 of, okay, each day. Okay. Speed of 30. So I have no idea what I'm doing. Hello?
Hmm. Hmm.
Yeah, I don't know what I'm doing.
Give it a try.
So
Give
use
it a try.
calculation
I'm
to
also trying
comment
on
on the
another
prediction.
slide, but let's see.
Okay.
Okay. Are you trying? Let's try it together. Let's try this one together. Okay. I'm on slide 2. See. Uh, let's first draw. Are you there? Okay. Can you hear me now?
Yes. Hello.
And you can see my screen as well.
Yes.
Okay. I'm on slide 2. Okay. Let's try it over here. Let me refresh this thing as well.
Okay. I can't see anything on my slide, but I can see your screen.
I don't know why my internet connection is extra non-cooperative today. Okay, Mr. Ammar. Mr. Ammar. Come on, yeah, it's too slow. Okay. No, 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 no. Hold on, slide 3, slide 2. You can hear me now, right? Hello? Hello, 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 hello.
Okay, I can hear you.
Okay, okay. So,
I can hear you.
okay, okay, okay. There is a slight lag in my voice. It reaches you after a few seconds. Okay, so here is
There's
this
nothing on slide 2.
spacecraft. Okay, it's moving in this direction, and at certain point of time, it starts releasing these ions, whatever they are. All right. Mass of spacecraft is how much? Mass of spacecraft is 4.
I rejoined. I couldn't hear you.
Okay, okay. Now you can hear me, right? Mass of spacecraft
I
is how
I
much?
I couldn't hear you since.
Okay, what I did, I simply said that there is this spacecraft traveling. There is this spacecraft traveling, and as it travels forward, after a certain point, initially, whatever it had within it, that thing, uh, it was moving with it. Now, so they had the joint, the same velocity.
I
Now these particles are being released. Can you hear me now?
hear you.
You can't hear
Now
me?
I can hear you.
Now you can hear me. Okay, so I'm saying the spacecraft, it's moving rightwards. Okay, your mic is mute. Hopefully now it would be better.
I can hear you.
You can hear me. The story of our life. I can
Sad.
hear you. I can't hear you. Can you hear me? He hears me. He hears me not.
Nice. Can you restart from the start?
Okay, you can see my screen as well, right?
Yeah.
Okay, so there is this boxed spacecraft which is moving rightwards. We are not concerned with the shape of the spacecraft right now. Okay, and it's releasing these particles, whatever, towards the left hand side. All right, these ions,
Mhm.
xenon. Okay,
Mhm.
so initially they are moving together with the same velocity, and after they are released with a certain velocity, and that velocity is in opposite direction to the movement of the spacecraft. Okay, so what's the mass of the spacecraft? Mass of the spacecraft is 486 kg. So I write, and I don't know
Mhm.
what its speed is, so I assume it to be I assume it to be x. U of
Mhm.
spacecraft is x. Okay, so now what's the mass of these ions being released? Let's say it expels a mass of 0.13 together at a particular point of the day. Okay, so 0.13, but does it release it all together or does it release, uh, let's say it released it together at one point of time. Okay, so
Okay.
mass of x, mass of xenon being released is 0.13, and mass of, sorry, u of this xenon is how much? U is the same as x,
Is it?
isn't it? I mean, the spacecraft
Okay.
is carrying this and it's carrying it together. I mean, you carry
Okay.
something and you're moving forward. And then as you move forward, as you run forward, you and the thing that you're holding, you have the same speed. So that's the initial proposition. That's the initial stage until this point,
Right.
before xenon being released. Then when the xenon gets released, we do not have the velocity of the spacecraft. We are told that v is equal to x plus 8.
Mhm.
V is equal to v of spacecraft. It says that spacecraft, it gains, the speed of spacecraft is predicted to be initially increased by about 8 meters per second each day. So whatever its initial speed was, it increases by 8.
Right.
And what the speed of xenon at the time of release, after that point, it is said to be 30 kilometers per second.
Mm-hmm.
So v of xenon is how much? V of xenon is uh, 30,000
30.
meters per second. Okay, so let me write all this in the form of m1 u1 and m2. uh, okay, so I have got u1, since u1 and u2 are common, I can write it as 0.13 plus 486 times x is
Mm-hmm.
equal to m1 I consider to be xenon. Okay, and I'm considering
Right.
motion towards the
Mm-hmm.
right hand side to be positive. That is why I have positive values for u1. X is towards the right hand side. All right, so v1,
Uh-huh.
the velocity of xenon after being released, it's in the opposite direction, so I'll take it as negative 0.13 into minus 30,000.
Mm-hmm.
Okay, and over here I will have plus 486 times v2 is x plus 8. It keeps on moving in the same direction.
Mm-hmm.
Okay,
Mm-hmm.
so this, I get 486.13. All right, over here, what is 0.13 into 30,000 minus 0.13 into 30,000? 3,900. So minus 3,900 plus, this is x, 486x plus 486 into 8. 486 into 8 is how much? 3,888. Okay, so I bring this to the other side. This becomes 0.100 plus 3,888 would be minus 12.
Minus 22. Oh, yeah, 12, sorry.
Mhm. So x will be equal to minus 12.1 divided by 0.13. X can't be negative. X can't
I mean,
be.
isn't it just the direction?
Hmm. But the
It's
direction
not
should also come as
the.
positive. 0.13 into the. Okay, what does the direction come out as? 12 over point. This is 12, right? Is it 12?
Yeah, yeah, it's minus 12.
Minus 12. Minus 12. 3900. 3900 is equal to. 3900 is equal to momentum. Hmm. 3888. Wait, did I make a mistake? M1 plus M2. 486 plus 0.13 is equal to X. And over here, I said 0.13, which is M1, and it has a velocity V1, which is in that direction minus 3000, plus 486 times X plus 8. So 486 times X is this 0.13x. 0.13x is correct. Minus 3900 plus 0.13 into 0.13 into 30,000 is 30,000. It is 3900, and 486 into 8 is how much? 3888. So minus 12 divided by 0.13 is what?
Oh, you have the calculator.
12 divided by 0.13 is 92 meters per second. But this gives me the value of x. This gives me the value of x. I mean, x comes out as 92 meters per second. But this does not prove that the gain in speed is the gain in speed is.
So it says comment, right? So it might
Okay. It
be
would be this way.
telling us.
Wait. No. See. This one was right. I mean, if we were to calculate the velocity, then this thing would have been right. But here we are. So the change in momentum for one would be equal to change in momentum for the other. When the spacecraft is releasing this xenon, when the spacecraft is releasing this xenon, what was the initial momentum of xenon before being released?
Same as the spacecraft.
It was zero. I mean, in the direction it's moving, it's zero. In the
Okay.
direction that it is eventually moving towards the left hand side, it was zero. Okay, so what is the change in its momentum? The change in its momentum is equal to uh, mass into change in its velocity, which is 0.13 into 39,000.
Mm-hmm.
Okay, and the momentum it has gained in this direction, it would have been gained. I mean, if it's again pushing off in this direction, the it would push off, the spacecraft would push off with the same change in momentum in the other direction. Remember what I told you about jumping off the earth? So the same thing.
Right.
So the spacecraft, it would move rightwards towards with that change in velocity. So this should be equal to uh, change in velocity is 3900 this way. For this one, it will be 486 into delta v towards the right hand side. Okay, so 486. Again, I'll explain it again. Wait, the spacecraft, let me do it on slide 1 now. Slide 1. The spacecraft, it's moving with a constant velocity. The spacecraft
Mm-hmm.
is moving with a constant velocity. Is there a change in momentum?
Mm. Yes.
There is no change in momentum as long as it is moving with a constant velocity. When the spacecraft is moving with a constant velocity, there is no change in its momentum. Okay?
Okay. But why?
If, because v minus mu, mv and u, they are both the same, so change in momentum will be 0.
Yes, yes, yes.
Okay? So if this xenon fuel is gaining momentum in this direction, it would be accompanied by a gain of momentum by the spacecraft in this direction towards the right hand side.
Uh-huh.
Okay, if the spacecraft, it gains momentum in the right hand side, so let's see what's the gain in momentum for the xenon and what's the gain in momentum for the spacecraft. So m
Mm-hmm.
delta v for xenon is equal to m delta v for spacecraft. Agreed?
Okay.
Mass of xenon is 0.1. Agreed?
Right.
Mass of uh, 486, that is the mass of spacecraft, but we do not know, or we are yet to prove what velocity will it gain towards the right hand side.
Right.
Okay, so 0.13 multiplied by 30,000,
Mm-hmm.
call this one xenon, call the spacecraft, this is spacecraft, this is xenon. Okay, so 0.13 into 30,000 divided by 486 is the mass. It gives you 8.02. So change in velocity is 8.02 meters per second, which is what the statement said. Hence, it is true.
Okay. Okay.
Shall I repeat once again? The momentum, if there are two objects and they have uniform momentum, change of momentum of one object will be equal to change of momentum in the other object in the
Mm.
opposite direction. Agreed?
Okay.
If two objects, they are in a uniform system, they are in a closed system, if one gains momentum, the other gains momentum in the opposite direction. Newton's law, third law, action reaction.
Mm.
Okay,
Mm.
if now we'll see what is causing this change of momentum. This change of momentum for this object is its mass multiplied by the change in its velocity.
Mm.
Okay, it would be equal to the mass times change in velocity of the other object,
Mm.
and then we just put in the values. Mass of xenon, the amount of kgs the spacecraft loses in one day, multiplied by velocity with which it is released, it is equal to the mass of the spacecraft times the velocity it will gain.
Mm-hmm.
Okay, and
Okay,
then you
got
solve
it.
for it and you'll get v is equal to 8.02 meters per second. Okay, 6a please.
Okay. Explain what is meant by principle of conservation of momentum. Okay. Principle of conservation momentum states that um, momentum before collision is equal to momentum after collision, meaning that momentum is neither created or destroyed.
Wow, nice. Correct.
I'm a
Total momentum
genius.
remains constant. Okay. Next part, please. The picture shows toy car initially at rest with a piece of modeling clay. A student carries an experiment to find the speed of the what? A
Pellet.
student carries out. I mean, where does this pellet come from? If you had a toy car, can I experiment to find the speed of pellet fired from an air rifle? The pellet is fired horizontally into the modeling clay. Subhanallah. The pellet remains in the modeling clay as the car moves forward. The motion of the car is filmed for analysis. Subhanallah.
Nice.
The car travels a distance of 69. Okay. Speed of car immediately after being struck by the pellet is how much? 1 meters per second. Can you show?
Car travels the distance. Okay. Rest of. Okay. No, I can't. Okay, wait. Let me actually try. Let me actually try. Okay, distance is 69, and then time is 1.3, right? So then we have distance and time. We need speed. I am speed. Okay. Speed is equal to distance by time. 69 divided by 1.3 is what, sir?
69 divided by 1.3. It's 0.69 divided by 1.3. You will have
Oh,
0.53.
0.53. This is the speed.
This is average velocity. Speed is equal to distance by time gives you average velocity. You're halfway
It's
correct.
average.
Next,
Okay.
we have to
And then
show u or v.
we have to show
V.
speed. I didn't even show that the speed of car immediately after being struck by pellet is about. Okay. So V. This is what?
This is average velocity. This formula, speed is equal to distance by time, it gives you average velocity.
Okay. So do we need that?
We actually, what happens is in our experiment, we are given this point mass and it's being struck on by some other thing. Okay, initially it was at rest, so u was 0, and after being struck, we are to show that its velocity is 1. What we calculated
Uh, okay.
speed.
We don't need that then, right? So V U is equal to 0. So S, I can just use another kinematic formula.
Hmm.
So V is equal to U plus 80, no? V squared,
I mean,
U
even with that one, you
squared.
could have done. Even with, okay, there are a couple of ways. Okay, first you try, and then I'll tell you how your initial solution could have also been converted to find this thing.
Okay. Um.
Okay, you're looking at the equations of motion. Which one to use?
Yeah,
Hmm.
I don't have A. I don't have A.
Hmm. That is
Which
why
one
that
is?
is why we'll have to use the one that you were using. We'll have to
Uh-huh.
use the one. So you said speed is equal to distance per time. Okay. Or all right, speed is equal to distance per time by 2. So 0.53 is equal to u is 0, v is v is v divided by 2. So 2 into 0.53 is how much?
One something, almost one. So yeah, one is equal to
1.206. V is equal to 1. Okay. All right. This shown. Then next one. State the assumption
state
that we made. Whenever,
state and
hmm, whenever we are using this average velocity thing, we are assuming the acceleration to be constant.
uh-huh.
Even for all the equations
Uh-huh.
of motion, for all the equations of motion, we assume constant acceleration.
Acceleration to be constant.
Okay, next part
Okay.
3. Show that the speed of pellet just before it collides with the car. Yes.
Okay. Mass of car and modeling clay. Uh, uh, uh,
Momentum question,
okay.
simple. Hmm.
Mass of car and clay is equal to 97. Okay, how many kgs is that? Isn't it 0.09731?
Hmm.
Okay, and a mass of pellet which is 0.84. S- huh? Okay.
Okay.
Pellet just before it collides, mass. Assume, okay. So we knew that V was 1 here, U was 0, V was 1, right? Right?
Uh, U of car was 0, good. V of car is 1, excellent.
Okay, here U is, we don't even need that, do we?
U of pellet we have to show, so let's put that as a question mark.
Okay. And then V
What would be the V
is,
of pellet?
um, V of pellet would be, the amount of time, it, same as the this thing car,
Excellent,
so it would be
excellent,
1.
excellent.
So, um, 97.31 into 10 minus 3 into 0 into 1.
So the car is initially at rest. I can simply put the total momentum of car MCUC as 0. make my life
Yes.
easy, but you can show it as multiplied with 0 as well. Then
Uh, uh-huh. And then 0.84
hmm,
into 0 and to
no,
you
no,
to
no, no.
know.
Hmm,
Uh, Question mark.
hmm. So all right, you're right. 0.84 multiplied by x. Let's call it x.
You.
U.
Okay.
Okay.
It is equal to you to 1v1. Okay. 97.31 into 10 minus 3 by plus 1, right? I mean into 1.
So it
Uh,
would be the same.
and then,
Hmm.
yeah, and so this one's also 8,
10
4
power
into
minus 3.
10 power minus 3. Yeah, you just do this and solve you. So,
0.84 into 10 power minus 3 is on this side, and on that side it's being added.
right. So just put this division.
Hmm. So it will be 9 point minus 3 divided by 0.84 into 10 raised to the power minus 3. These cut out. 9.31 it is. 9.31 plus 0.84 divided
Isn't it
by 0.84.
97.31?
It is 97.31
Yep.
plus 0.84 divided by 0.84. I get 116.8 meters per second, almost 120.
Yes. Okay.
97.3. Okay, good job. Next one, please.
The modeling clay is removed and is replaced by a metal plate of same mass. The metal plate is fixed up to the back of the car. The experiment is repeated, but this time the pellet bounces backwards. Explain why the speed of toy car will not be greater than the original experiment. Greater than in the original experiment. This is because the momentum of the bullet is not combined with the momentum of the car. It doesn't become one closed thing.
Uh, Pellet bounces back. Momentum.
It does not increase the momentum because it's going
Okay.
back.
So what is happening is previously momentum of car plus momentum of pellet. Now the velocity of the car is greater. You're saying. They're saying.
Mm-hmm.
Okay. So momentum of car plus momentum of pellet. This is before collision. It was momentum of pellet, and then it became after collision of car plus pellet. It became one body, car plus pellet. Now what is happening? Initially we have got momentum of pellet, but after momentum of car, if I take the initial direction of momentum as positive, momentum of car minus momentum of pellet,
Mm-hmm.
because it's moving in the opposite direction. Okay,
Mm-hmm.
so previously, okay, this, all right. So momentum of pellet, we don't know if it would be the same or it would be different, but does it say it would go back with the same velocity? It does not.
Hmm.
It does not say. Pellet bounces, just says that it bounces backwards. Okay. So momentum of car, previously it just had the mass of car.
See now mv, right?
Hmm,
Momentum of pellet,
hmm.
uh, and v will be much more, and it'll be different because it's going to in the opposite direction, right? See, because it was one before, v was one, and then the what do you say?
See it this way. Before collision, their momentum of pellet it was. So now it will become this thing. Instead of over here, I write this thing over here. And momentum of car afterwards. This is after collision in second case. Okay. This, if I make it go to this side, if I make it go to this side, it will be, or let me do it in a relatively neat way. Did you get this step? So before collision, their momentums are same. So I'm saying after collision, and A is equal to B, C, sorry, A is equal to C. So I'm saying B is equal to C. I'm putting B is equal to C, right?
Hmm. Okay.
In both cases, the momentum before collision was MP, momentum of pellet. All the momentum there was, it was momentum of pellet, right?
Mm-hmm.
So this is A in both cases. And before,
Okay.
in the previous experiment, what it said was that before collision and after collision momentum. So before collision momentum was A, after collision momentum I'm calling it B.
Okay.
This is experiment. Collision is same as in the experiment 1, it's A.
Uh-huh.
After collision, it has a different value than it has a different equation than that of first experiment. In first experiment it was just one combined mass and their combined momentum. Okay, now it's different. So I'm simply putting this B is equal to C.
Uh-huh.
Okay, so what I get now is plus momentum of pellet, sorry, minus momentum of pellet. Agreed?
Uh-huh.
If I make this go to the other side, this MP, it will become experiment 1 momentum of car plus pellet plus experiment car. Got it? Or did it become too gauge pitch?
It became too much.
Okay, okay, okay. Let me simplify it again. Slide 3. There is momentum of pellet plus car. Agreed?
Yeah.
Experiment 2. There is just momentum of pellet before collision, the same value as in the first experiment.
Right.
But after collision, there will be a momentum of car and there would be momentum of pellet in the opposite direction. Agreed?
Right.
So I call this one B and this one C.
Okay.
A is equal to B, A is equal to B, A is equal to C. So now I am saying B is equal to C. Can I say that?
Right.
Okay.
Sure.
So let me write that over here. So if I say B is equal to C, it means what is B? Experiment
MB
1,
plus C.
experiment 1, momentum of pellet plus car. And what is C? Experiment of pellet minus it would be. Agreed?
Uh-huh. Right.
Okay. I move this momentum of pellet to the other side. So experiment that pellet bounces back at an angle 72 degree to the horizontal. Wow. Explain why the car would move even faster if the pellet goes back at same speed.
Because
If it goes at 72 degree, if it goes at 72 degree, and that is v, horizontal velocity will be how much, or horizontal
70
momentum will be?
uh, momentum of pallet cos 72.
Cos 72 is how much? It never exceeds 1.
You are calculator man.
Wait. I'm also the equation man at the moment. The thing is that uh, let's see this. This one would become, we're talking about x-axis. This is x-axis. This is x-axis. Mass of car, momentum of car is at x-axis, and then momentum. I should have used p for momentum, but anyways, momentum of pellet. Momentum of pellet in x direction. X direction. So I'll simply take the x component of that momentum, which will be cos 72. What is the value of cos 72? What is it saying about velocity?
So let's just go to the next question, please. My
Directly.
headache.
Okay, just last thing. Just last thing. Uh, in this case, you were right. This one would be cos 72. Okay, and if the velocity
Nice.
is same at that particular angle, now this component has become smaller. If this component has become smaller, this later momentum will become smaller, and it means that the later speed is now smaller.
Nice.
If it moved back at the same, I mean horizontally, fired horizontally, goes back horizontally, the car would go faster. If it bounces, hits, and bounces back at an angle, the later momentum of the car would now be slower.
Yes. Okay. Next question.
Okay.
Oh no, it's the same question.
Now instead of car, you have got a hanging mask. Hanging mask, and the results.
Yes.
The student tests the results of experiment by firing a pellet into a pendulum with a bob made of modeling clay. They calculate the energy transferred. Data. There are no mathematical errors, but the student's answer for the speed is too small. Explain which statements in the calculation are correct and which statements are wrong. Now he's doing a different experiment. Now he's not firing into the clay attached to the car. He's fired
Hmm.
into a clay hanging from a string.
Yes. Okay, let me do this. Change the vertical height pendulum.
You'll just have to he has done the experiment, he has done the data and calculations. You have to tell which statements are correct and where is flaw in his experiment.
Yes, yes, yes. Mass of pendulum and pellet. Mass of pellet. How come mass of pendulum and pellet is less than just mass of pellet?
Very good.
Okay, and then
You're reading from my
vertical.
screen?
No,
Okay.
and then how come vertically it changes height
I mean, if you fire into something, it would go swinging.
back?
And as it goes swinging, I mean, initially you push it, and let's say you fire from the right hand side towards the left hand side, it goes towards the left hand side, and obviously it will gain some height since it's attached to that string.
Yes,
So that's the height it's talking
yes,
about, 22.6 cm.
yes, 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 yes. Uh, Tension. Energy of kinetic energy pendulum pellet immediately after collision. Therefore, kinetic energy pellet immediately before collision. So that doesn't make sense.
What doesn't make
Does
sense? Change in
does it?
gravitational, change in gravitational potential energy.
Kinetic
Yes, almost. I mean, state your problem. I mean, the problem that you find in this statement.
pendulum and pellet immediately after collision. Both of them are 0.16, and then just one of them, which is pellet, before the collision is 0.16, which does not.
0.16. Change in gravitational potential energy of pendulum and pellet. For this one, they have used the formula mass, the combined mass, even though we have an objection to that, but they should have used the combined mass. Okay, fine. Carried forward. Then we know that gravitational potential energy is mgh or mg delta h, change in gravitational potential energy, right?
Yeah.
So they are doing 71.6 10 raised to the power minus 3 correct, 9.81 correct, 0.226 meters correct. So this would be the change in gravitational potential energy. Fine. But but this would be when you have hit the pendulum swings and gains the maximum height, not immediately after you hit the pendulum.
Hmm.
Because this thing, it would take some a few seconds or milliseconds to swing and reach the maximum height, right?
Right.
So that is the time when the it will gain gravitational potential energy. So if it gains gravitational potential energy by that time, initially right now it has ke, but this ke, is it equal to the combined mass of the two, or is it equal to the just because of the pellet? Should combined mass be used to calculate kinetic? Does the pendulum have kinetic energy
Yes.
before being hit or immediately at the point of being hit? The pendulum does not have kinetic energy. All the kinetic energy is provided by the pellet.
Yes.
The pendulum was stationary. The kinetic energy was provided by the pellet. So it should have been calculated using the velocity and the mass of the pellet.
Yes.
Okay. So
Yes.
this statement is wrong to put the two equal. Therefore, kinetic energy of pellet C, and it's wrong to put these two equal. Kinetic energy of pendulum and pellet immediately after collision. Immediately after collision, they're saying immediately after collision. Okay, 0.16 here, that is correct. Therefore, kinetic energy of pellet before collision. In fact, he has done it right. 0.16. I don't see a fault in it. EK after collision, kinetic energy transfers into gravitational potential energy. That is correct. That is correct. Okay, does it say elastic or inelastic collision somewhere?
No.
Mm, change in vertical height. I mean, we'll have to say that this is based on the assumption that collision is elastic. If the collision is not elastic, then kinetic energy won't be conserved, and it won't be inaccurate to say that potential energy gained is equal to kinetic energy provided. Some kinetic energy will be lost.
Right.
Okay. Okay. And if some energy is lost, then this after collision energy, it will not be equal to before collision energy for this particular pellet. Before collision energy will be larger. Some will be lost as heat and sound, perhaps.
Okay.
Okay. And did they do? Hopefully, they did the calculation correct. Half mv squared. So if you have got 0.
It says no mathematical errors.
No mathematical errors. Okay. Okay. Shall we keep it till here for today, or do one more question? We can do one more.
Okay, we keep it. We keep it.
We keep it. By the way, we have left with just one more. Okay, we'll do this one more question in the next class and then proceed on to the next topic. Uh,
I guess.
tonight,
Okay.
tonight,